All right, so let's implement Radix sort. I've created a project. I've put the code into package academy.learnprogramming.radix sort. I've created our array that we're going to sort. It's the same array that we went through in the slides, and I have code for printing out the array after the sort. We're going to create two methods, one called Radix sort and one called Radix single sort, and you'll see what those do in a minute. So let's start with Radix sort. So we'll say public static void Radix sort. We're going to accept our input array, the radix, and the width. Remember that for Radix sort, all the values have to have the same radix and the same width. And then we're going to say for int I equals 0, I less than width, I plus plus, and we're going to call the Radix single sort method that we haven't written yet. And we're going to pass the input I and the radix. And so basically what we're doing here is we're going to call Radix single sort for each position in our values. And so we have a width of 4, and so we're going to loop 4 times, and each time we call Radix single sort, it'll do the sort based on one of the positions. And as you'll see, it'll start with the rightmost position and then move to the rightmost -1 position, etc. So it'll be moving along the digits from the least significant digit to the most significant digit from right to left. So let's write the Radix single sort method. So we'll say public static void Radix single sort, and it takes the input array, the position, and the radix. And so the first thing we're going to do is we're going to say int num items equals the input array dot length. So this just stores how many items that we're going to be sorting. And then we're going to say int count array equals, and we're going to create a count array that's large enough to hold all the possible values. Our radix will be 10 because we will have digits 0 to 9, and so we'll have a count array of length 10. And then we're going to say for int value input, so for every value in our input array, we're going to count how many values have a certain digit in whatever position we're looking at. And we're going to have so we're going to call get digit, and we're going to write this method in a minute. And we're going to pass the position, the value, and the radix. And this method is going to return the digit. So it's going to return 0 to 9, and then we're going to increment the count by 1. So when we pass the first value, 4725, 5 is going to come back as the digit, and so we're going to increment count array 5 by 1. So before we go any further, let's write the get digit. I'm just going to remove this blank line here. We don't really need it. Let's write the get digit method so you can see what it does. So we'll say public static int get digit. It accepts a position, a value, and the radix. And it's not a difficult method. It's going to return value over. We're going to cast this to int because we don't want to have a floating point value returned. And it's going to pass math.pow 10 position modded by the radix. Okay, so what the heck is this doing? Well, the math.pow method takes the first parameter and raises it to the second parameter. We've passed in position 0 because here we're starting at 0. So we've passed in 0 for the position. We have 4725 for the value and 10 for the radix. And so we're going to get math.pow 10 raised to the 0, which is 1, because anything raised to the 0 power is 1. And the division operator takes precedence over the modulo operator, so we're going to divide the value by 1. 4725 divided by 1 is obviously 4725, and then we're going to mod that by the radix, which is 10. Well, 4725 divided by 10 is 472, and the remainder is going to be 5, and so that's what we're going to return. And so for position 0, we're always going to be returning what's in the ones position. So let's say we call it get digit with position 2 instead. So instead of calling it with position 0, we called it with position 2, which would mean that we're handling the hundreds. We'd have 10 to the power of 2, which is 100. We'd divide 4725 by 100, and we'd get 47, and then we'd mod 47 with 10, and that would give us a remainder of 7. And so we'd return 7 for the hundreds position. If we wanted the tens position, this would be 1. And so we divide 4275 by 10, and we'd get 427, and then we'd mod that with 10, and the remainder would be 7. And so that's how the get digit method is figuring out what the value of the digit at each position is. Okay, so we're turning back to our radix single sort method. For each value, we're going to get the digit at the position, and on the first call, that position will be 0. So we're going to be returning all of the 1 positions. And so it's going to increment the count array. It's going to count all the values that have 0 in the ones position, all the values that have 1, 2, 3, etc. So by the time we finish this loop, we have a conventional count array where all we're doing is counting the number of values that have a specific digit in their ones position. But we want this to be a stable counting sort, and so we're now going to do the step that we discussed in the slides, and we need to adjust these counts so that instead of having just raw counts of how many values have a specific digit, we want each position in the count array to contain how many values have that digit or less than that digit. And so as I said when we went over the slides, all we have to do to get that is sum up all of the counts up to and including the digit that we're working on. So to get the number of values that have 3 or less in the ones position, we have to sum up the counts in positions 0, 1, 2, and 3. And so let's do that now. So we'll say for int j equals 1, we don't have to handle the first index because the number of values that have 0 or less in their ones position are going to be the number of values that have 0. So we don't have to worry about changing the first count. We just have to worry about changing the counts in positions 1 and beyond. So for int j equals 1, j is less than the radix because that's the length of our count array, j plus plus, and we just say count array j plus equals count array j minus 1. And so what this loop is doing is adding up. If j is 3, it'll add up indices 0, 1, 2, and 3. And assign, and that'll be what count array 3 ends up being. If count array is 5, it'll add up indices 0, 1, 2, 3, 4, and 5. That's what count array 5 will end up being. So at the end of this, I'll put a comment in here, adjust the count array. And so at the end of this loop, the count array has been adjusted. So instead of containing raw counts, it now contains the number of values that have that digit or less than that digit in the position that we're working with. And so at this point, we're going to do the step that we went through on the slides where we're going to copy the values into a temporary array. We're going to work from right to left so that we're preserving the relative ordering of duplicates. And so we're going to create that temporary array. So we'll say int temp equals new int, and we need that to be enough to hold the number of items we have. So we'll say num items. And then for int temp index equals num items minus 1. So we're starting at the end. Temp index greater or equal to 0. And we're going to decrement it. On each iteration, we're going to say temp minus minus count array, and again we're going to use get digit, position, input, temp index, radix equals, and this is going to equal input temp index. Now, when we went through the slides, I actually called temp index K. So we're doing exactly, this is the exact same code we went through on the slides. And so we're working from right to left, and we're looking at the count array. We're decrementing, remember, using the prefix operator. So we decrement the value at the count array for the digit first, and then we use that index to index into the temp array, and we assign the value at input temp index, because that's what we're working with. And temp index starts at the end of the input array and moves right to left. So because we're moving right to left with the input array, and because we're writing from right to left in the range of positions occupied by a specific digit, we preserve the ordering of duplicate values. So if you're confused by what this code is doing, go to the last video because we went through it there. Just keep in mind that I called in the code that I showed you, temp index and K are one and the same. Okay, so at this point, we've copied our values into the temporary array. They're in sorted order in the temporary array. So the last thing we have to do is copy them back from the temporary array into the input array. So we could use system.array copy, but let's just do it using a regular old loop. So for int, let's use a temp index again. Temp index equals 0. Temp index is less than the number of items, and we'll just increment it. Temp index plus plus. Input temp index equals temp index. Nothing earth-shattering going on here, just a regular old loop. And so to recap, we do the counting. We just get the raw counts of how many values have a specific digit at the position we're working at. We then adjust those counts. As we saw in the slides in the last video, we then write the values into a temporary array, as we saw in the slides in the last video. And in the final step, we copy the temporary array back into the input array, and then we return from this method. And when we return here to radix sort, the values have been sorted based on that position. And as you can see, we're going from 0, 1, 2, 3, 4, 5, etc., depending on the width. 0 is the rightmost position. It's the least significant digit. That's how this getDigit method operates, because it raises 10 to the position. Actually, there's a mistake here. This should be radix. All right, so the final thing that we have left to do is to actually call this method. So we're going to call radix sort, and we're going to pass it our radix array. That's our input array. Our radix is 10 and our width is 4. And let's run. And we have 1330. 1594, 4586, 4725, 5729, and 8792. We have sorted our array. And remember that the key thing here is this has to be a stable sort. And so that's why we're doing these extra steps. We need a stable counting sort here. An unstable counting sort will not work because it would undo previous sorts when we've sorted on less significant digit positions. So we've done extra work here to make our counting sort stable, and because of that, our radix sort is able to sort these values. All right, so that's it for sorting algorithms right now. We're going to see a few more later in the course after we've covered some more data structures, because they make use of those data structures. But for now, that's it. So I'll see you in the next video.